Nearly 100 years ago, the great RMS Titanic came to rest at the bottom of the North Atlantic. More than 1,500 men, women and children were killed when the ship went down. To this day, much of her destruction remains mysterious. But there are clues hidden in the cold and dark. Her torn and twisted wreckage still has a story to tell. Now, for the first time, a full-scale forensic investigation will tackle the case. An arsenal of high-tech hardware will perform a deep-sea examination. Pieces of Titanic will be dissected and analyzed. New techniques will reveal aspects of the tragedy never before witnessed or understood. Battling hurricane winds and hostile seas, investigators will work to unravel secrets nearly a century old. Titanic's true and dramatic story may finally be told, as scientists uncover answers from the abyss. Some 300 miles off the coast of North America, in the dark waters of the Atlantic Ocean, a group of ships has come together at the Titanic site. Experts from the United States, Great Britain, Canada, and France have convened with one goal. Their mission? To conduct the first full-scale scientific investigation of the Titanic disaster.
If there's any opportunity to try out this innovative technology during the first leg.
We don't really know at this moment the attitude of the ship when it hit the bottom.
Surprisingly, the destruction of Titanic is still mired in myth and controversy. But this unparalleled team of investigators hopes to set the record straight.
Now what we're seeing, this is the questionable area right in here.
Immediately following the Titanic disaster, the world struggled for answers. Soon, a popular story emerged that seemed to explain everything. Titanic struck a mountainous iceberg. She sustained an enormous gash and sank in one piece, killing more than 1,500 people. For nearly 100 years, this was the accepted account of what happened that tragic night. When Titanic's wreckage was discovered in 1985, the world was shocked to learn there was more to the story. The great ship was actually torn in two huge pieces. Her bow and stern separated by nearly half a mile. To this day, we still don't know how the ship broke and scattered across the sea floor. This group hopes to change all that.
There's a tremendous amount left to be learned about the Titanic. Bringing these minds together, we should be able to come up with a pretty good answer to what happened, why it happened, and in what sequence it happened.
To reconstruct the disaster, the team at sea will work with investigators on land.
At the rear end of the bow.
Together they will focus on Titanic's wreckage,
In the main wreckage field next
a forensic approach likened to studying a corpse in a murder mystery.
to give everybody a feel for it. The word forensic immediately conjures up images of pathology labs and someone poring over cadavers. And to a certain extent, we're doing that. What we are doing is looking for signals and signs and often very small pieces of information to build the bigger picture.
From its position.
Four major events surrounding the destruction of Titanic are still shrouded in uncertainty. What is the true extent of the iceberg damage? Scientists now suspect it's a series of small slits, not a 300-foot gash. But can they prove it? They also know that Titanic broke into pieces the night of the disaster. But how did this actually happen? And why? One of the biggest mysteries is what occurred when the ship left the surface. How did the bow survive the 2.5-mile descent relatively unscathed? And what happened to the stern to utterly destroy this part of the ship?
Ship's heading is 150. All right, Kurt, 100 up. 100 up, I got 100 up. One in.
To answer these questions, the investigators divide the wreck site into two fields of operation. The crew aboard Ocean Voyager will concentrate on Titanic's bow, which lies more than 12,000 feet below. To reach their target, they'll deploy the Magellan 725. Magellan is a remotely operated vehicle, or ROV. For this mission, Magellan is equipped with state-of-the-art underwater cameras.
Kirk, if you can stand in front of the camera, I can get a flesh tone off you. Set this up. That's good.
Once Magellan reaches the Titanic site, its powerful lenses will become an investigative research tool.
Magellan will be able to get a very close-up look at the whole structure, at various pieces of debris down there, and be able to pick up what we hope are a lot of visual clues. We'll get detail like nobody has seen before.
To launch Magellan to Titanic requires a 15-ton crane and an 8-man crew. The robot is attached to the ship by a cable thousands of feet long. Magellan will receive instructions and transmit live images through this umbilical cord.
Troy, you got me all balled up. I'm all stopped. Let me know when you're close. We're close. Bring your head, 90 right, 100 full up. Getting wet, Kurt. Okay, let me know when you want hydraulics. Hydraulics up. Hydraulics are on. Pull that tether a little bit. Troy, start working on the depressor. Yeah, get that swing out.
As Magellan now fights the current on its 3-hour trip to the site, a half-mile away, the crew aboard Nadir prepares its mission to the exploded stern. Little is known about this part of the wreck. The manned submersible, Nautil, is being turned into an advanced photographic platform. Heading up the effort is oceanographer Paul Mathias. He outfits Nautil with high-resolution cameras and powerful deep-sea lights. Pictures of the stern wreckage will be fed into this tiny sphere and stored on computers designed for the mission.
We are about to try something that's never been tried before. Very exciting.
Nautil now begins her long trip to Titanic. A voyage that will take her crew to one of the most inhospitable environments on Earth. Temperatures are freezing. The water pressure is bone-crushing. All that will protect her crew is a 4-inch thick titanium shell. Nautil and Magellan are now underway on an historic mission. It's hoped their photographic reconnaissance will add a new chapter to understanding the Titanic disaster.
In the past, ships have vanished, and it was walk away and leave it because there was nothing could be done. Now we have the technology to visit these wrecks, look at them in detail, and to understand why they failed and why they were lost.
We're going to presume that you'll be coming in on the bow, on the starboard side.
Aboard Ocean Voyager,
Obviously,
scientists meet with the Magellan team
that's
to
where
plan their
it's
search for the actual iceberg damage.
Coming in with the side shell. So we want to
Bill
try
Garsky
and see if
is a
there's
naval
any
architect
possibility of
and a leader in the field of marine forensics.
at this point in the hull.
I think
David Livingstone works for Harland and Wolff, the shipbuilding firm that constructed Titanic.
there is a potential entry into the hull.
These men want to find and photograph a section of the damage that doomed
It
the
is a
ship.
rather jagged hold. There is some obstructions.
When Titanic's bow struck the ocean floor, it plowed up sediment, concealing the deadly iceberg damage under a mound of mud. In 1996, scientists used sonar to peer through the silt. Their data suggest that the iceberg caused a series of thin slits that flooded and sank Titanic. Today, investigators wonder if part of the fatal damage might not be buried in the mud.
Made some calculations, or there was something that.
In fact, it might be visible to the naked eye.
I think if we can find some exposed surface of the ship that was not in contact with the sediment, perhaps, and I say that perhaps, we may find the iceberg damage that the ship sustained.
Before they can begin looking, the pilots must fly Magellan to Titanic's bow. A risky endeavor.
Roger that, heading down.
As the ROV approaches the bottom, it pauses to check its tethering system for tangles.
It's settling out. Things are getting safer. Another 20 meters, 090, Bruce.
More than 2 miles of cable floats freely through the deep sea. This is more than enough to get snared on any wreckage at the site.
Moved 50 meters, 280, roger. Stand by, Bruce.
We are a tethered vehicle. We go all the way from the surface to the vehicle on the bottom. Obviously, we do not want to get that tether fouled. And the Titanic is a major fouling obstacle.
After several hours, Magellan reaches the sea floor.
You're looking at bottom right there.
The landscape is desolate, barren. Somewhere in the darkness lies a colossal structure, once 4 city blocks long and more than 100 feet high.
12 foot, dead ahead. Something's real close. There's the wreck. All right, 6 feet off, come on up. It's pretty close, don't get closer. Watch your verticals.
Titanic's bow is a haunting sight. Surprisingly elegant, despite its destruction.
Troy, nice job aiming those lights.
Roger that.
The Magellan team runs the cameras through a series of system checks before they begin searching for the iceberg damage.
Hey, Emil, how we doing? You're all right down there? Or no?
Yeah, we're cool.
Okay, so
Livingstone and Garsky test the skills of the Magellan pilots. In order to find what they're looking for, they fly dangerously close to the wreck.
Doesn't actually look like this.
They head to a spot where one survivor claimed he saw damage nearly a century ago.
What we believe is some damage with the ship either.
On the night of the disaster, deep below the luxurious accommodations, survivor Frederick Barrett is working in Titanic's boiler rooms. Barrett helps stoke the boilers, which supply steam power to the engines. After Titanic hits the iceberg, chaos erupts in the boiler rooms. Barrett is among those who struggle to save the ship. Barrett sees water jetting in 2 feet above the floor grate in boiler room 6. An hour later, he's forced to abandon an adjacent boiler room.
A large volume of water came through. All at once, I saw a wave of foam come tearing through between the boilers, and I jumped for the escape ladder. Leading fireman, Frederick Barrett.
Patiently, the team slowly combs the outside of the wreck, looking for the damage Barrett saw from inside. To pinpoint Barrett's location, the team drops down the starboard side of the ship, counting hull plates and portholes as they descend.
I'm still trying to go down. Am I clear on the left?
This is the only way to find the exact area described by Barrett.
See how that thing goes in and out?
Yeah.
With every second, Magellan gets closer to the target destination. If they can find the damage, it will be the cornerstone of their investigation. After hours of searching, Bill Garsky spots something in the encrusted wreckage. It's 4 o'clock in the morning.
Okay, is this the opening you're talking about?
Yeah, almost right on the mud line. There's something that looks like an open seam.
Hidden near the mud is a tiny opening in Titanic's side.
Yeah.
Yep. Yeah, that's an open seam.
You're kidding.
It is. See the room through it?
Yes.
And it's right where Frederick Barrett said it would be. It's a section of the actual iceberg damage.
Okay, let's get in there real tight and frame it up.
An elated team savors the discovery.
You can hang there, zoom in. Yeah, there you go.
I want to give credit to Stoker Barrett because he said he saw the seams open 2 feet above the floor plate, and that's where we are. There it is.
Okay, Ron, request is that you get the ROV as close as you can to that opening.
Upon closer inspection, the damage is telling. As suspected, it's not a puncture or a gash, but rather something more simple. A separation of steel plates. The plates should be held together by rivets, but rivets are missing. Some scientists have long suspected that rivets may have failed upon impact with the iceberg.
When the iceberg came and actually hit the ship, at the seams, the rivets could be failing. And by failing, we essentially feel that what would have been happening is the heads of the rivets would have been popping off. Okay. Once they pop off, the seams can open, you can have water coming in. Okay. The question is, why would those rivets fail?
Start right at this depth. Yeah.
Before Magellan is called back to the surface, it scours the ocean floor looking for loose rivets.
Yeah, I couldn't get more than about 20 or 30 degrees.
Using the ROV's robotic arms, the pilots collect a steel sample with rivets still intact.
See if I can hold still and let it clear up a little bit. Maybe get it under and just hold it up.
The sample is carefully placed in a retrieval basket for the long journey back to Ocean Voyager.
7's on the cage, bending it. Backing up.
Tight.
Okay, you ready to pick them up?
Yeah. All right, secure lights and hydraulics. Okay, lights, hydraulics down. Got enough boom.
The following day, Weiss begins his work by thoroughly photographing the specimen. Next, he carefully removes the rivets. He'd like to know why they might have failed. At the time of Titanic, ships were held together by rivets, not welds like they are today. It's estimated that more than 3 million rivets were used to construct Titanic. Each beam, each piece of hull plate was attached to the ship by rivets. Titanic's rivets were made of wrought iron, which is essentially a mixture of iron and a substance called slag. At the time, it was difficult to monitor the mixture of slag and iron. And if too much slag was added to the mix, it could actually weaken the rivets. Investigators would like to know if this is what happened in Titanic's case. In a temporary lab aboard Ocean Voyager, Tim Weiss continues the search for answers. First, he cuts a cross-section to look inside. Weiss collaborates with materials scientist Tim Fakey, who's testing more rivets at the National Institute of Standards and Technology in Maryland. It was Fakey's past work that prompted further study of the rivets.
We sectioned 2 failed rivets that were recovered in '96, and looking at them metallographically under the microscope, you could see that the rivets had too much slag. So what we wanted to do in 1998 was to get more rivets from different places on the ship.
Working together, Fakey and Weiss examined rivets of all sizes. Rivets used in different applications. They're measuring the quantity of slag, which is seen under the microscope as dark streaks. Some rivets have the optimum amount of slag, and the substance appears as little round particles. This sample, on the other hand, has too much slag, which will weaken the rivet. In their work, Fakey and Weiss continue to see variation in Titanic's rivets.
We've looked at rivets that are from various locations on the ship. Overall, 5 to 10% may be having a problem on the ship. We've looked at 30 out of 3 million rivets. So we're never going to be able to say definitely, but the trend seems to be there. The more rivets we look at, it doesn't go away.
Fakey's work raises provocative questions. Were small, flawed iron rivets Titanic's Achilles' heel? Or was the impact forceful enough to compromise even the strongest of rivets? We may never know for sure. In any case, we now know the damage that sank Titanic was quite small.
I think psychologically it was just unbelievable that something so small could have caused the loss. It had to be seen as catastrophic, and that was the perception of the day. Now, with hindsight and looking at the evidence, it's entirely possible for ships to be lost with quite small holes that can't be controlled.
For Bill Garsky and David Livingstone, the investigation is off to a successful start. But the work for these 2 men is far from over. The weather for the expedition so far has been very cooperative. Gentle swells make daily commutes a pleasure. These motorized boats, called Zodiacs, are a critical link between ships at sea. Today, expedition leader George Tulloch heads to Ocean Voyager to discuss the weather that lies ahead. Conditions can change very quickly here. Hurricane season has officially begun, and the Titanic site lies well within a known hurricane zone. The team is keeping its eye on Hurricane Bonnie, which has the potential to hit the site with devastating force.
See, this has shifted. Before it was coming.
Bonnie will have to be watched closely.
Has it going much further north?
Deep below the surface, the conditions here are still ideal. For the past several days, Paul Mathias and the crew of Nautil have been capturing the most detailed photographic record yet of Titanic's stern.
I'm going to sharpen up the exposure. I'm going to open the shutter. Nautil has the ability to move very, very precisely over the seabed, And while we're moving back, and Nautil has the ability to move very, very precisely over the seabed. And while we're moving back and forth, we will be firing the cameras at the bottom.
Each of the images that Matthias captures is like a piece in a jigsaw puzzle. As the pictures are assembled, scientists build a unique view of the entire wreck. This process is called photomosaicing.
The pictures are there to tell a story. What the mosaicing does and what the individual videos do is to reveal a story within this wreckage. And each piece has its own little story to tell.
Scientists can now clearly see some historic and dramatic locations. On the stern, the third-class stairwell comes into sharper focus. The night of the disaster, this was a place of confusion and panic as passengers tried to escape the ship. Titanic's furthest aft deck also becomes more visible. Near these decks, many received last rites from Father Thomas Biles, while others took their chance by jumping into the icy waters. On the ship's bow section, the davits used to lower lifeboats can be seen with striking clarity. Officer Charles Lightoller worked here for a brief period, evacuating Titanic. The mosaic also reveals the grand staircase. Today, it's a ghostly remnant of what it once was. With painful reminders of its past elegance. This skylight looks into Titanic's wireless room. A piece of the radio still hangs precariously from the ceiling. The night of the disaster, Harold Bride and Jack Phillips frantically sent out calls for help from this room until the water poured in. For the next several days, Matthias and the crew of Nautil photographed the wreck piece by piece. It will take thousands of images to complete this historic mosaic of Titanic. Late at night, Magellan heads back to Titanic.
Yeah, wait till we get around here and get the taglines on.
Investigators now turn their attention to one of the most astonishing events of the Titanic disaster.
Keep that loop outboard, because it's going to go up top.
The moment the great ship breaks into pieces.
Can I bring up hydraulics? Just tilt that pan and tilt down.
Bueno.
Let me know when I'm in the water.
You're in the water.
Okay, bring your head 90 right. 90 right? Okay, coming right.
To this day, much of the Titanic's breakup is shrouded in mystery. For passengers and crew, this was a time of utter horror. For those who witnessed the breakup and lived to talk about it, it was a terrifying spectacle.
You could see her propellers and everything. Her rudder was clear out of the water. And then her lights went out. Able seaman John Bewley.
We pulled from the Titanic for a distance of a city block when Titanic began to shake to pieces. First class passenger Lucille Carter.
While laying on a bundle of chairs, I could see the ship split in two. There was a rain of wreckage, and a big piece of timber fell on me, striking my vest. August Weichmann.
Today, investigators will comb the wreckage, looking for clues that might help to explain Titanic's violent destruction. Magellan approaches an area near the stern, known as the debris field. As it reaches the sea floor, Magellan sends power to its lights.
All right, looking 240, 600 feet out. Heading is 215.
Yes, we are in the south of the debris field, south of the stern. I don't know exactly at which distance, but probably 200, 300 meters or something like that.
Dead ahead, 60 feet. We're coming in some stuff.
The wreckage in this area is staggering.
I got a nice big target at 270.
Massive sections of the ship stand like giant monoliths.
I'm gonna get right up above these things and look down in. Okay, it's gonna take me a little while to get over there.
Each piece has a story to tell.
Just stamping another 35. You want to get lower now? Yeah, turn right.
But deciphering what the wreckage means is incredibly complicated.
There's so much stuff around here. It's really difficult to figure out where it came from.
The process of interpreting the wreckage to reconstruct the disaster is called reverse engineering.
Looks like something that's definitely got ripped. Any ideas what that was?
It's the same approach investigators use to understand modern disasters, like airplane crashes.
Okay, I'm just gonna pan it to the right real slow.
Among the scattered remnants, the team locates a series of boilers. Each more than 20 feet tall.
This is pretty tall here. Roger.
These boilers may yield significant clues.
Yeah, because there is here one place, maybe there's one here.
Yes.
Some survivors believe Titanic's boilers exploded, contributing to the breakup of the ship.
Fireboxes.
Investigators want to know precisely what happened on that terrifying night. During the tragedy, as Titanic is being evacuated, some survivors say they hear the massive boilers exploding, breaking free and tumbling from the ship.
While I was helping with the boats, there came explosions below deck, and the ship took a rushing in of the icy waters on the boilers. August Whiteman.
I heard 4 distinct explosions, which we supposed were boilers. First class passenger, Mrs. Stewart White.
As the investigators inspect the stern boilers, they can find no evidence of explosion.
The boilers from number 1 boiler room. It's a single-sided boiler. It seems in perfect condition. Therefore, it didn't explode or implode.
To be sure Titanic's other boilers didn't explode, investigators have to account for the ship's remaining units. Their search takes them to the bow section, where many of the boilers were housed. The decks here have collapsed, concealing a view inside the ship. But to the team's surprise, some wreckage has slipped away. For the first time, investigators can clearly see into one of the boiler rooms.
And what we found was all 5 boilers in place with no explosion damage. It gives us an indication that probably all 24 boilers that were in operation didn't explode and didn't leave their foundations.
If the boilers didn't blow Titanic apart, what could have caused it to break into pieces? Investigators now turn their attention to the steel itself. Could it have been flawed, contributing to the breakup? It's a highly contested theory. To settle the debate, the team needs physical evidence. An actual section of steel that broke free from Titanic. Investigators would like to cut a sample from a 20-ton section of hull dubbed the Big Piece. The piece is being raised as an historic artifact. But to the crash investigators, it's important for other reasons. The artifact came from the starboard side of Titanic, encompassing 2 upper decks of the break region. If it is weak, it could mean much of the steel here was also brittle. For retrieval, the artifact is connected to giant lift bags, which carry it 2.5 miles to the surface. Here, salvage teams work quickly to connect the piece to the recovery ship, a bay supporter. Suspended underwater, a piece of Titanic once again is touched by sunlight. As the crew works, they're careful not to cause any damage to this historic artifact.
Come on up. Bring it over to the side. Turn it around. Okay.
Despite their best efforts, it's difficult to control the massive weight in high winds.
This rope tight now, okay?
After several tense hours, a section of Titanic's hull is safely secured. David Livingstone and Bill Garsky now have a tangible link to Titanic's rupture.
Hey, look at this, right here.
We hope to learn much more about how the Titanic broke up.
There's been a lot of
and perhaps make a better explanation why the vessel is in the state she's in today.
The gravity beating those stairs, I don't think it was.
Yeah.
Evac. Probably lead.
As the big piece makes its way to Boston for analysis, the expedition team monitors Hurricane Bonnie, which has stalled near the Atlantic seaboard. The hurricane is pushing bad weather their way. Nervousness underlies the proverbial calm before the storm. Many of the crew take advantage of the sunshine. It's hoped that rain and rough seas are all that hit the site, and that the hurricane never gets any closer. For now, it's a tense waiting game. The big piece arrives in Boston after a 4-day journey. In the harbor, materials scientist Tim Fakey meets with Titanic conservator Stefan Pennick.
On that side, you see a very flat edge over here, this region when we disassemble it. The big piece came from very close to the region in the stern where the big break occurred, where the ship broke up. So if we have a piece of the hull from right next to the breakup, it is entirely likely that that has steel that's very similar to the steel that was actually involved in the break. This part?
Can you put that on the light? The steel looks perfect.
Back in his lab, Fakey prepares a sample cross-section of the steel. Using what's called a fracture toughness test, he will measure its strength. This machine will subject the steel to forces in excess of 2,500 pounds. It's a slow bending process, similar to what Titanic went through the night of the disaster.
See opening down there? When the stern of the Titanic came clear of the water, the upper surface of the ship was loaded to several times its design strength. And how the materials react to this huge load is going to determine what happens to the ship. There you go. That's nice and tough.
As it turns out, Titanic's steel is surprisingly strong.
The steel shows toughness almost as good as modern steels and was actually quite adequate for the application of the Titanic. Okay, this is nice.
Fakey's work has helped to settle a debate that's raged for nearly a decade.
This is nice, tough material.
Investigators can now say with certainty that Titanic's steel was not flawed, and it did not contribute to the breakup of the ship. Next, investigators shift their focus to another potential cause: the powerful flooding of Titanic.